We're continuing with Christian apologetics, and in all this, currently, we are proving that there must be a God, that this universe cannot be explained except that there is someone above nature who has created it. And we start off with today's quote. Today's quote is from Isaac Asimov, a rather famous writer. He is long deceased. In 1982, he gives this quote, "Emotionally, I am an atheist. I don't have the evidence to prove that God doesn't exist, but I so strongly suspect that He doesn't that I don't want to waste my time." And this is an interview that he gave in 1982. And this goes to show that, first off, there's an emotional response to it, that emotionally I'm an atheist, but also in the fact that Isaac Asimov, who is a science fiction writer mostly, but he wrote about all kinds of stuff that one would wonder, how do you know anything about that? I don't think you're any kind of expert at that. You're just writing books is what you're doing. But anyway, he said he can't prove that God doesn't exist. Well, I would have to say that if Isaac Asimov can't prove it, you can't prove it either. But this morning we're going to start with a protected place, because we are living on a place that does have protection built into it. It is here. And we just start off this way. Job 26 and verse 7, He stretches out the north over empty spaces. He hangs the earth on nothing. How did Job know that? The Greeks, at a much later date, believed the earth was being held up by Atlas. You have others at a much later date than the book of Job who have the earth being held up by some sort of object or by some sort of animal, by something. But Job says it hangs on nothing. Well, how did he know? Had he been out into space and saw that in fact it was just hanging there on nothing? I don't think he did. Isaiah says this, Isaiah 40 and 22, "It is He who sits above the circle of the earth, and its inhabitants are like grasshoppers who stretch out the heavens like a curtain. He spreads them out like a tent to dwell in." And here is this in poetic terms, that of the heavens and of course us as grasshoppers. Now here is that circle of the earth that Isaiah does write about, and it's that this is one of the shots from Artemis 2. But yeah, here is the horizon of the earth, and you can see the atmosphere. It's more clear over on the other side. But let's talk about this for a second. Here is our solar system. We have now, I was taught that Pluto was a planet. I'm not going to argue about that. I got Pluto in here. That's just the way I was taught, and I guess I'm a Plutoist. That I give Pluto the credit. It's a planet. But this is just showing how our solar system is. And of course, the closer you are to the sun, the faster you're going to go. The further away you are from the sun, the slower you're going to go. Mercury has a year of 88 Earth days. So if their new year on Mercury is January 1st, well, they've already come back around to a new year already, and now into another year. 88 days has already gone by. For something like Pluto does a complete orbit around the sun in 248 Earth years. That's a long time. And for the planets to align, for 6 of them, as many as 6 to align, it's about every 100 years. For more than 6, as in all of them, going at least to Neptune anyway, that hasn't happened since January 1st, 1665. And it's not going to happen anywhere in our lifetime or even in the next generation, next generation, next generation. That seldom happens, but it doesn't affect the earth anyway. It doesn't affect us if they align. It really doesn't do anything. But here is just this also is from Artemis 2. This is a solar eclipse beyond the moon. It's on the other side of the moon, looking back. In here, you can see Saturn, Mars, and Mercury out there, and they're just absolutely beautiful. That's a stunning photo. But that's from the other side of the moon. That's at a distance on the other side of the moon. Now I've just thrown this in. This, of course, is a solar eclipse here on the earth. And as seen from the earth, both the sun and the moon are the same size. That's why you can get a total eclipse. And you have what's known as the corona around the moon. And from our standpoint, though the sun is considerably larger than the earth and larger than Jupiter, from this, just by way of distance, as we view it, they are the same size. Now, we come to this. This is called the ecliptic. Is that all of the planets, their orbits are on the same plane. I don't know if you knew that or not, but they are on the same plane. And this is that planets do not cross orbits. That would be bad. There would be collisions then. None of them cross orbits, and this is order on a pretty massive scale and for a specific reason. It's for us. That it would be bad if we crossed the orbit of Mars, because that means potentially at some point we would collide. And that would be devastating. But outside of this, all right, where there isn't human life to protect, well, all things are off. You have this. This is where two galaxies actually have collided. All right, that would be enormous. A catastrophe beyond anything, beyond scale. But this is what, if our solar system looked like this, it would be terrible, actually, that you have potential collisions or even getting close to something like Mars, even if you didn't collide, would affect it would affect the tides, it would affect a lot of things on the earth. And no telling what it would do to the weather, no telling who knows what would actually happen. But years ago, it was at a VBS, it was a bit of software that was a lot of fun, and the kids enjoyed doing it. And it was to show how difficult it is to have a sun and your planet and keep your planet alive. Okay? You got to decide the mass of your sun. You got to decide that. You also got to decide what your planet is made out of and its mass and a few other things that were there. And then you hit go. And then you went to see how long your planet survived. And it was not easy. Quite often, what would happen is that you'd have your Earth that you just created, it goes really close to the sun and gets slung out. All right, it's gone. It's gone. It burns up getting way too close to the sun, so you just lost everything living then. And then it gets thrown out and becomes a chunk of ice. Others who were playing around would discover that, okay, our sun has too much gravitational pull, and there was nothing, that your planet just kind of drifts off. And well, that's no good. And the whole point was that you are highly intelligent and you can't do it. How is chance going to do it? Chance can't do it. Chance only brings about disasters more than anything else. But there's no way that life could just develop here by chance upon chance upon chance upon chance. Now here is another thing concerning the earth, that the earth is on average 93 million miles from the sun. That's on average. We are in an elliptical orbit, not an absolute circle, an elliptical orbit. So there are times when we are closer to the sun, and there are times when we're farther away from the sun. But on average, we're 93 million miles from Earth. Now, if we were to decrease that by 10%, I've got this other Earth over here. So that we're basically 83,700,000 miles on average, well, we would burn up. If we were to increase it by 10%, that's 102,300,000 miles on average, we would freeze. We're in the exact spot we need to be. Now, Venus is at 67,000 miles. 67 million. Is it? No. Yeah. Venus is at 67 million, and Mars is 154 million. And we're in this spot of perfection. We're in this spot that is absolutely right. And we come to this quote. This is Hazel Muir from 2007. The rare Earth hypothesis. The rare Earth hypothesis uses the Goldilocks principle in the argument that a planet must be neither too far away nor too close to a star and galactic center to support life, while either extreme would result in a planet incapable of supporting life. Such a planet is colloquially called a Goldilocks planet. Everything is just right for us. Sounds like we're getting awful close to Genesis 1 and 2. Sounds awful close. That this is tailor-made. Would you say? Of course, they're not about to say that. This is a bespoke planet, a tailor-made planet, just for us. Yes, it is. Prove it wrong. Yeah, there's pain. Yeah, there's going to be accidents. Yeah, there's going to be matters of weather. Sure, there's going to be doing that. There is death, and we can show where that enters the world in Genesis chapter 3. And it is a direct result of sin. And sin is a monumental problem. All right? And here is this everything absolutely perfect. And we have these words. There's anthropocentric or anthropocentrism, which basically means that's made for mankind. It looks like everything appears to be perfectly suited for mankind, as if this were made for us, and everything serves us on this world. And Genesis 1 and 2, reading that's exactly what we'd expect to find. And there's so many things that we could ask, okay, if the Bible is true, what would we expect to find if the Bible is true? And you can list them one after another, after another, after another, after another. And it doesn't have to be just scientific. It could be historic. It could be concerning human nature. It's a wide assortment of things. That of the home which begins in Genesis 2. And so foundational to humanity. All right? This is precisely what we would expect. Psalm 104 and verse 14, He causes the grass to grow for the cattle and vegetation for the service of man, that he may bring forth food from the earth. It is tailor-made for us. Everything about it is. No, we can't breathe water, but we breathe air, and you learn. Go underwater, you hold your breath. Or you better take something with you so that you can breathe. Yes, there are things that kill upon this earth. Polar bears, sharks. There are things that are painful on this earth. There are things that can happen of hurricanes and earthquakes and volcanoes and the like. But by and large, You know, if this world were so destructive, we wouldn't be here. And here we are. What, 7 billion, if that's a true number? I can't dispute it. I can't confirm it either. But there's an awful lot of us here. That's not a complaint. The earth is in fact protected in many, many ways. And we're just going to look at this for a second. On the inside of the earth is a massive amount of iron. And it's molten. Now, have we seen this? No, we haven't. We haven't seen it. But evidently, what is occurring is proof that it's got to be there. That deep inside the earth, there must be an enormous amount of iron, and it would seem like it would have to be molten inside this because it produces the magnetosphere of the earth, which plays a very important role. You have the sun bombarding us not just with light, but with all sorts of particles of radiation and various other things that the magnetosphere is a shield against it. Now, you leave the earth and you go to the moon may not be protected by that magnetosphere. I guess if you had the earth between you and the sun, perhaps you would be. But yeah, there's the protection is not there anymore. You leave the earth and protection's not there. Go to another planet, the protection's not there. It's not going to be there. There's only a few planets that actually have a magnetosphere, just a few, and not very many. And here's just a little animated thing to show you basically how it works. And this is showing. This is the aurora borealis, and it is caused by the Earth's magnetosphere and the solar winds on that magnetosphere. That's how we can actually witness it. There's another photo of it. And we also have, here is our atmosphere, and it obviously we have to have this, and the atmosphere is perfect for us. We need oxygen, correct? Correct. Our atmosphere is not 100% oxygen. What would happen then? If it were 100% oxygen, well, that's too much oxygen for us. But aside from that, any little spark and it's done. Okay? We become a fireball. And there's enough oxygen for us to live, but there's also enough of other things in there. Nitrogen, CO2, we exhale that. There's enough of that to where you can light a fire, and the fire does need the oxygen to burn, but it doesn't burn up the entire atmosphere. All of that is protection that is built into all this. Now we come to gas giants, of which these are not. Gas giants and moving objects. These are moving objects in space. And we do get them. Halley's Comet is one, and Halley's Comet comes around every 76 years. And of course it misses us, but it is visible. It is visible. And there are, in fact, protections out there from gas giants. We go back to here. That is, in between Mars and Jupiter, there is what is known as the asteroid belt. And it is basically, it's huge. Now, we can't really see it from the Earth as far as I know, if we can see it. Maybe we can. I don't know. But there is that asteroid belt that is there. And we'll get to that a little bit later. But here is you have these enormous giants. Jupiter and Saturn are out there. And you have the other three, and I do count Pluto, you have the other three that aren't giants, but they're still out there. And these giants, here is Saturn, and here is Jupiter. Yeah, that's crazy. But it does show you, I know it's very, very fast, but it does show you all this in motion. That's not static. That is, you're not looking at the ground. You're looking at violent storms, and we discussed that last week, I guess. But this is something that occurred, and this was Shoemaker-Levy. You're looking at Jupiter. Shoemaker-Levy in 1994 slammed into Jupiter. And you can see where this all occurred. Shoemaker-Levy was a comet, and Jupiter got in its way. And it goes right into Jupiter, better Jupiter than here, I will have to say. Now we come to the asteroid belt. Asteroid belt also concerning moving objects in space, because the asteroid belt just orbits the sun. And by the way, the rings of Saturn, neither the rings of Saturn nor the asteroid belt could remain stable for billions of years. They can't. They will eventually collapse. They will eventually disappear. And you can't have all that either rings around a planet or rings around a solar system with all these asteroids because they're not that stable, and they cannot survive for billions of years. They will begin to collapse, and they will begin to become unstable in all of this. But here is, the red, the yellow circle. That is where the belt happens to be. And it serves a purpose also of being kind of a filter of things that are heading into our solar system, that they can also act as blocking things. And we do have some significant things out there. There's Ceres. That looks like a planet or a moon. It's not. It's neither one. That is in the asteroid belt. Here are some others. I think that's the biggest one that they know of. Here are some other ones that are in that belt. And all of it protects us. All of it. And everything has a purpose out there. And God has put in these measures. He has a creation that He created it on week 1, and we haven't managed to find the end of it yet. We're still catching up. After all these centuries, we're still catching up to what He created then. And there's also, we'll get there hopefully in a bit. It's going to take us a bit. But there are things that we have seen today and witnessed today and also recorded today that if you had witnessed it a couple of centuries ago, if you survived from it and came back to tell people, they wouldn't believe you. They wouldn't believe you. It would be too fantastic. But that now we see it with technology. We can go to places like places underwater and see things that no one would have taken seriously a couple of hundred of years ago. But now let's talk about life. We're going from space. Now we've got to address life. Where did life come from? First off, we look at the law of biogenesis, or the biogenic law. That is a law. Anything that breaks a law is flawed, because laws of physics are not broken. Laws concerning science are not broken. If they are broken, then you have to say it's not a law. But this is a law, and it goes like this. Well, wait a minute. No. Law of biogenesis. Life comes only from life, and that of its own kind. Can't come from anywhere else. All right, you don't have rocks and dirt suddenly living today. You don't have things just springing up out of nothingness, which was the popular thought going back a few hundred years ago. That was the popular thought. There was no knowing, how did those mice get here? Well, they sprang from nothing. I mean, that was the thought. They sprang from nothing. How did those maggots get there? It was thought they sprang from nothing. It just happened. But with the law of biogenesis, life comes from life, and that of its own kind. And that is, all of this is important, but of its own kind, which is spoken of in Genesis. Then God said, Genesis 1:11, let the earth bring forth grass and herb that yields seed, and the fruit tree that yields fruit according to its kind, whose seed is in itself on the earth. And it was so. It yields fruit according to its kind. It yields seed according to its kind. And it doesn't make any kind of change from an apple tree. Now the apple tree is pumpkin. All right, that doesn't happen. And we know it doesn't happen. It doesn't happen. I meant to get a slide for this, but I kept forgetting. I'd have the brilliant idea, I need to put that in, but I kept forgetting. But there was, years ago, it was in Egypt, in a tomb. And they knew that the tomb was at least, they knew it was about 2,000 or so years ago. And they found in that tomb wheat. Whole grains of wheat. Of course, in Egypt, it's very arid, and this had been stored underground in, I assume it was in a jar. So it's been stored in the most, a place where it would preserve. And so, just for the sake of doing it, they planted some of that wheat. And guess what came up? Wheat. Not much different than what Egypt grows today. Not much different at all. That was recognizable wheat. It wasn't something, non-wheat. That wheat since then has evolved into something else. That was wheat. And it's seed after its own kind. You plant an apple seed, if anything grows, it's going to be an apple tree. Start off as a seedling, then grow larger, and then at a certain point of maturity, it's going to start growing apples. And the earth brought forth grass, the herb that yields seed according to its kind, and the tree that yields fruit whose seed is in itself according to its kind, and God saw that it was good. You don't have a developed... Now, we have varieties of apples, and apple varieties can still be made of where you're taking these two varieties, and let's see what we get in the process. Let's see what we get. We'll cross-pollinate these things and see what happens. And that happens to this day, but you still get an apple. And what it is proving is that the genetic code put into apple trees as well as people is extraordinarily powerful. Extraordinarily. Genesis 1, verse 13 now. So the evening and the morning were the third day. That is a literal 24-hour period. Now we go to Genesis 1, verse 22. So God created great sea creatures and every living thing that moves, with which the waters abounded according to their kind, and every winged bird according to its kind. And God saw that it was good. We have the same wording here concerning animals. Whether in the sea or in the air, it doesn't matter. That while you can have a variety of finches, you still have finches. You can have a variety of pigeons, but you still have pigeons. You can take this pigeon with the fuzzy feet and take this pigeon that doesn't have that kind of feet, the feathery feet. You can put those two together and you get a different variety of pigeon. All right, it's still a pigeon. We now go to verse 24. Then God said, let the earth bring forth the living creature according to its kind, cattle and creeping things and beasts of the earth, each according to its kind. And it was so. And God made the beasts of the earth according to its kind, cattle according to its kind, and everything that creeps on the earth according to its kind. And God saw that it was good. Everything is put in place fully, completely, to where dog kind is here, cattle kind is here, bird kind is here, of the various sorts of birds. They're all here. And while there can be varieties, such as with dogs are a dog is still a dog. You can have a toy poodle, or what do they call it, a teacup poodle maybe? But and you can have a mastiff. They're still dogs. And actually they do recognize each other as dogs. It's like, we're in the dog club. I don't know what happened to you, but we're in the dog club. And but here is the law of biogenesis. Here are some of the men responsible for that. First is from the 1600s, Francesco Redi. He is on this. 100 years later, Lazzaro Spallanzani, he's from the 1700s. Then we get into the 1800s. We have Louis Pasteur and John Tyndall. All right, all of them are doing experiments and coming with the fact that there has to be this. You can't have things, living things, just springing up for nothing. They have to be coming from parents. They have to be coming from somewhere. And yeah, they are working on and discovering the law of biogenesis. And the common belief going back, even back to Pasteur's day, going even that late, you had the idea of spontaneous generation, that living creatures arise from non-living matter, and this occurs. It's common. This just happens all the time. You just accept it, and evolution embraces that belief, and it embraces a belief held before the 17th century. Now they want to make a claim that creationists are taking people back scientifically. Creationists are not. Creationists are the ones that found the law of biogenesis, and it is a law, and they are the ones taking us back before the 17th century in this. All right? And mice cannot spring from nothing. They've got to have parents, just like other animals must have. Now, we come to Charles Darwin. Most consider him a genius. He writes Origin of Species, but in fact, he plagiarized his grandfather. It is his grandfather's work that he's working on. And there are those that recognize, yeah, he did get it from his grandfather, because his grandfather wrote books. And it's kind of funny that he never gave his grandfather any credit. Well, you may think it's funny, but I would say it's plagiarism. All right, and his grandfather was Erasmus Darwin, and Charles had a degree of all things in theology, not in biology. Now, here is his book, and they want you to know it as The Origin of Species and by means of natural selection. Okay, they want you to know that title, but I doubt you can read that, but I put it up larger. It is The Origin of Species by means of natural selection, or the preservation of favored races in the struggle for life. That's what that is, and we're upholding that man. I don't know why. I don't know why you would, because he's on the team that's anti-God. That's why. That's why you do it. And a whole lot of hypocrisy going on out there of where they will hold that man up while saying that is wrong. Well, I'll agree that is wrong. Toss him out with it. Toss him out with it. Now, well, he's got to be their hero, and this is his grandfather, Erasmus Darwin, and this is the book he wrote, Zoonomia, or The Laws of Organic Life. He wrote that. It was his work. And here's the thing concerning Charles Darwin and the origin of species, is that he ignores the origin of life. Everything here in living, he just takes it matter-of-factly. Yeah, it just is. Now let's explain how you have different finches. Well, you just ignored a huge problem there. He just attempts to show how we have variations of living things without answering the question, well, how do we have living things anyway? How is there life anyway? How did life, you got a problem, how did life come to be? How did it even arrive to where you can have something like finches? And he only speculated with pre-existing life. Things were already living. He's speculating with pre-existing life and never attempted to answer where life came from. And Darwin's work is limited to conjecture through ignorance and avoiding the difficult. That's what he does in his book. And he doesn't even try to give any kind of answer as to where life came from. And I keep mentioning finches because that is part of what he was talking about in his book was finches. It's not the only thing. But in the Galapagos Islands, there were unique finches that are there. Well, that's easy to answer. And actually, earlier in the book, at the beginning of the book, he answers his own question. He answers his question concerning how do you have all these different types of finches. All right, well, he used to have a hobby of raising pigeons and breeding pigeons. And he very well knew that if you take this variety of pigeon and this variety of pigeon, put them together, you get another variety of pigeon. He knew that. And then if you take that other variety of pigeon and match it with this other one, you're going to get something else. He knew exactly how it worked, but he's got to do this whole thing of natural selection, which, there in the animal world, you have, if an animal isn't strong enough, it's going to die. Of course, all animals are going to die. But if it's not strong enough, a predator is going to get that animal. And that animal is, you can say, called. It is. And that the stronger animals are going to survive longer. Now, Darwin looks at variations of finches, but never attempts to answer how finches are capable of being alive, and all that's taken for granted. He just jumps to finches. Now, living things are way too complicated to replicate. It can't be done. In the best of laboratories, in the best of settings, in the best of technology, you cannot create life. You have to have something that's already living, and a seed is already living. That came from a living plant. You have to have something alive to have something else alive. It can't be replicated. It can't be explained how they came to be naturally. That can't be explained. No one can in fact do that. Now we come to this, which this is a jump. This is quite a jump. This is from 1924 and 1929. You have these two men who came up with what is commonly referred to as the primordial soup. All right, this is the beginning, actually just prior to the beginning of life on earth. This is the explanation that is given. And it doesn't work. Matter of fact, it's silly. But that's all you have to work with. Okay, so I was told, I remember as a student, I was told of imagine this green ooze that's that's out there, and it's just bubbling over with all kinds of whatever it is, and that's your primordial soup. Well, my question is, how did it get green? You have to have algae or plants or something already there for it to be green. It can't even be green. It'd have to be like muddy or dirt. It'd have to be, or even clear water. You can have water, but you can't have really that ooze there. But in this primordial soup is just, it would have to be like clay, mud, dirt, rock, things like that. And the whole story is this: one day, lightning struck that pool. And from that, in that pool, there was carbon, hydrogen, water vapor, and ammonia all there. And then amino acids are created by that lightning strike. And from those amino acids, you have the building blocks of life. But there's a big problem in that. One is it takes more than amino acids for a living cell. Number two, this thing not only would have to come to life by way of amino acids, but also be able to replicate itself so that there can be the next thing that can replicate itself and the next thing that can replicate itself for there to be any life whatsoever. All right, it doesn't work. Now, here's another thing. I'm not going to get too technical because I don't understand everything about it myself. But it is well known that electricity hitting something like this pool or electricity hitting something like mud or the ground, yeah, it can produce amino acids, but those amino acids will only be what are known as right-handed amino acids. You could think of it like the only half of a zipper. Okay, if you have like let's just say the right half of a zipper, it doesn't close. You have to have both halves of the zipper. Then you can zip it up. But this is only right-handed amino acids, and they do nothing. They're just sitting there doing nothing, if they were ever created anyway. But they're just sitting there. Now we come to Michael J. Behe. And he is a professor of biochemistry at Lehigh University. And he came up with the idea of irreducible complexity. And he actually was an atheist who, when looking at, he is a biochemist, when looking at biochemistry, came up with the understanding that a single cell is far too complicated. It's far more than amino acids. And it takes an enormous amount of complexity for it to live and function. And it can't happen by accident. And he realized that. He realized he was looking at something far too complex for you to just have a portion of it and it's okay. You have to have an extraordinary amount of things present. Now, we've run out of time today, but we will continue on irreducible complexity next week. Then talk about that of more concerning living creatures, and that there had to be a very, very wise, creative being behind it. Thank you to everyone, and hopefully we'll see you next week.